Let's look at a few examples involving polar coordinates. So we can look at how we can plot polar coordinates on the polar plane, and then we can look at how we can convert coordinates either from rectangular to polar form or from polar form to rectangular form. The idea of a polar coordinate is that it looks like an ordered pair, just like an x and a y coordinate. But instead of x and y, which are horizontal and vertical distances, we're going to be looking at r comma theta. So r is distance from the origin or from the pole, the center of the graph, and theta is the rotation. So just like in the unit circle, so it's the rotation around the origin. So for our first example here, we want to plot the point, the coordinate 3 comma pi over 4. So again, you might look at that and think that, well, that's just 3 units to the right and pi over 4 units up. So you could think of that as an x and y coordinate. But context tells us that this is a polar coordinate. So the problem says it's a polar coordinate. So instead of 3 being an x and pi over 4 being a y, that 3 is a radius, an r value, and the pi over 4 is an angle. Okay, so to plot this point, we need to go to the pi over 4 angle. So right here is pi over 4. It's in the middle of the first quadrant, right? And we need to go out to the third, in a radial distance from the origin, we need to go out 3 units. And the way the graph is structured, again, is we have these concentric circles, and each circle represents one distance further out from the origin, from the pole. So we want to go out to the third concentric circle. So we go 1, 2, 3. So along the pi over 4 angle, we go to that third circle. And so that would be where 3 comma pi over 4 would be located. All right. So our second point is negative 5 comma 5 pi over 6. So this one's a little different because we have a negative radius. So normally if you thought of x being to the right, a negative x value would be in the opposite direction to the left. So if we have a radius that's positive, it goes in the direction of the angle. So we saw in that first point, we had the pi over 4 angle. And so since the 3 was positive, we traveled 3 units from the origin in the pi over 4 direction. Well, if the radius is negative, then we're going to travel in the opposite direction. So to plot the point negative 5 comma 5 pi over 6, we want to first find the 5 pi over 6 angle. So 5 pi over 6 is over here in the second quadrant. And then instead of plotting the point in that direction, we actually want to go diagonally in the opposite direction. And it will be on the fifth circle outwards. So 1, 2, 3, 4, 5. So this is where a negative 5 pi over 6 is going to be located. Okay, it's actually on the 11 pi over 6 angle. So instead of writing negative 5 comma 5 pi over 6, I could just as easily say this is a positive 5 comma 11 pi over 6. So one of the weird things that we have with polar coordinates is that there are actually multiple ways that we can express the same coordinate. So I can express this one point in the polar plane as a negative 5 comma 5 pi over 6 or as a positive 5 11 pi over 6. So that's 2 ways to describe that same point. And technically, again, since we're talking about rotation around a circle, there's infinitely many ways that I could locate or describe the coordinates for that point, because it would just, I could keep rotating around the circle. And so we could keep thinking, we could keep listing coordinates or expressions for that coordinate using coterminal angles. Okay, so instead of 11 pi over 6, we might have 23 pi over 6, right? So again, that's something that we have to get used to because we're not used to seeing that with our x and y coordinates. So with polar coordinates, there are multiple ways to express the same coordinates or the same location. All right, let's try another example here. This time we want to plot the coordinate, the polar coordinate 4, 2 pi over 3 on the graph. And then we want to convert it to what its equivalent rectangular coordinate would be. So to plot it first, we want to look at the 2 pi over 3 angle. So 2 pi over 3 is in the second quadrant, and 4, we're going to go out a distance of 4, so go out to the fourth circle. So 1, 2, 3, 4, and that would be at 4, 2 pi over 3. All right, so that's a point in the second quadrant. All right, and then if we wanted to convert that point into its rectangular coordinates, so the equations or the formulas that we can use to convert from polar to rectangular, to find the x coordinate, we can use r cosine of theta, and to find the y coordinate, we can use r sine of theta. And that really just comes from our right triangle trig. So if we have a point and we know its x and its y dimension, that's the horizontal and vertical. So those do create a right triangle. And if the radius is the diagonal distance, that's the hypotenuse, then finding that acute angle inside is just right triangle trig, right? And so the cosine of the angle would be the adjacent over the hypotenuse, so x over r, and the y coordinate would be the opposite over r, so that's going to be sine. So we get these two equations, x equals r cosine theta and y equals r sine theta, just by applying our understanding and our knowledge of right triangle trig. So just to evaluate it real quick, to find our x coordinate, we know r is 4, and we know theta is 2 pi over 3. So to find x, I know x has to equal 4 times the cosine of 2 pi over 3. I know the cosine of 2 pi over 3 is going to be a negative 1/2, and so x is going to be a negative 2. And similarly for y, we're going to have y equals 4 times the sine of 2 pi over 3. And I know the sine of 2 pi over 3 is going to be a positive square root of 3 over 2. And so y is going to be a 2 times square root of 3. So this 4 2 pi over 3 polar coordinate can be, or is equivalent to the rectangular coordinate of negative 2, 2 root 3. Okay, and if you just to kind of make sure that this actually does work, that this is true, where would the point negative 2, 2 root 3 be located on the xy plane? Well, since the negative 2, the x value is negative, and the y coordinate, the 2 root 3, is positive, this would be in the second quadrant. And that's where we actually plotted the polar point. The 4, 2 root 3, or 2 pi over 3, was in the second quadrant. So that does seem to match up with what we've been thinking. All right, for this last example, let's look at how we can convert in the reverse direction. So if I'm given a rectangular coordinate, how can I convert it to a polar coordinate? So we saw the two equations to convert from polar to rectangular, right? X equals r cosine of theta and y equals r sine of theta. So we need two more equations to convert from rectangular to polar. So we can use r squared is equal to x squared plus y squared, and then we can also use the tangent of theta is equal to y over x. So these are the two that we can use. If we know x and y, we can then find r and theta. Okay, so in this example, we have our rectangular coordinate is 7 square root of 3, negative 7. First, we'll find the r value. So we're going to use the equation r squared is equal to x squared plus y squared. So r squared is equal to 7 square root of 3 squared plus a negative 7 squared. When you square things that are being multiplied, like this 7 times square root of 3, we can think of distributing that square. So it's 7 squared times a square root of 3 squared. So 7 squared is 49. A square root of 3 squared is just a 3. And then a negative 7 squared is a positive 49. So then r squared is going to equal 196. And to find r, we're going to take the square root of both sides. And so when we do that, we're going to get the square root of 196. And remember, we always have to do plus or minus when you take the square root of both sides of an equation. So we have to think about this in terms of a positive radius and a negative radius. And it turns out that the square root of 196 is just 14. So r could be a positive 14 or a negative 14, and we're going to have to figure out which it is. And it just involves the pairing that we do with our angle. To find theta, we're going to use the tangent of theta is equal to y over x. And we know that y is a negative 7 and x is a 7 square root of 3. So we have the tangent of theta is equal to a negative 7 divided by 7 square root of 3. And the 7's cancel, which means tangent of theta is really just equal to a negative 1 over a square root of 3. So where is tangent equal to a square root of 3, and where is tangent negative? So tangent is negative in the second and fourth quadrant. So we need to come up with an angle in the second and the fourth quadrant. And I know that tangent is equal to a 1 over root 3 if my angle is a pi over 6. Okay, so I need a pi over 6 angle in the second quadrant. So that would be 5 pi over 6. And I also need an angle in the fourth quadrant. That would be a pi over 6 angle. And so that's going to be 11 pi over 6. So I have two possible values for r, a positive 14 or a negative 14. And I also have two possible values for theta, the 5 pi over 6 and the 11 pi over 6. Okay, so how do we match those together? Okay, so let's go back to our original point. We know it's 7 square root of 3, so positive x value, comma, negative 7, which is a negative y value. So this original coordinate with a positive x and a negative y is actually a point down in the fourth quadrant. Okay, so remember that whether we have a positive radius value, positive r value, or a negative r value, the positive radius value gets paired with the angle pointing in the correct direction. Okay, if you're talking about a negative radius value, it has to point in the opposite direction. So in order to use the positive 14, I need to use the angle that points into the fourth quadrant. So I'm going to have positive 14 and an 11 pi over 6. So that would be one way to represent this coordinate in the fourth quadrant. So r is a positive 14 and theta is an 11 pi over 6. And again, that's because 11 pi over 6 is the angle in a fourth quadrant and 14 is the positive radius. The other option is what happens if I use the negative 14. Okay, so if I use a negative r value, that means the angle has to be in the opposite direction. So opposite of the fourth quadrant is the second quadrant. So if I use a negative 14 for r, then I need the 5 pi over 6 for theta. So here are the 2 points, one with a positive radius and one with a negative radius, both of which have an angle between 0 and 2 pi. And that's usually going to be pretty typical. We always want our angles between 0 and 2 pi that represent that given coordinate of 7 root 3 comma negative 7.